Hi guys, today we are going to be solving a problem called 3-sum. This is an extension of the 2-sum and 2-sum 2 problem. So I recommend that you first solve that and then come to this. Okay, so in this what we are given is an array of numbers. What we have to do is return an array of solutions such that when we add three numbers, the sum is equal to 0. You could see that here. Okay, so this is what we have to do. Now let me write the example here. So the brute force would be to take consider all the sub arrays of size 3 and then check if their sum is equal to 0 or not. And how would we be doing that? We will be having three for loops. Okay, so three nested for loops. So how it would be going is first we would be fixing this one, and also we would be fixing this one, and then we would be iterating through this. We will be checking if this sum is equals to 0. Yes, this is equals to 0. So we would be adding all three of this to an answer. Okay, and then after we would be moving forward, we will be checking this is not equal to 0, we will be moving forward, this is not equals to 0, we will be moving forward, this is not equals to 0. Now because we finished all of those, what we will be doing is moving this one forward. Okay, and then we will be checking from this. Now this is not equals to 0, we move forward, this is also not equals to 0, we move forward, this is also not equals to 0. And then because we finished that, we will be moving forward, checking. Now this is equals to 0, so we add that to the answer array. Then we move forward, this is not equals to 0. Okay, then again we move forward, we are here, we add this is not equals to 0. Now we finish this one. So what we do, we increment this pointer to here, and then we have this, we start from this. So this is how it is going to be going. So for I equals to 0 to n minus 2, j equals I plus 1 to n minus 1, k equals j plus 1 to n. So this would be 3 to minus 1. So this is how this would be going. Okay, so the time complexity for this would be O of n cube because there are three nested loops as you can see here. Now coming to the space complexity, if we don't consider the answer array as part of the memory, or it is not taking any memory, then our answer would be O of n. If it is taking memory, then it would be O of n. But in this case, we would not be considering that, so it is O of n. Okay, so this is the brute force. Now, could we do it in a more optimal way? If you think back, we did have an optimal solution for the 2-sum. So can we use that in here to get an even more optimal solution? Let's just say that. So for the optimal solution, what we could do is use the previous solution that we have from the 2-sum 2 problem. So what we would be doing is, let me just write this array. So what we would be doing is for each element that we have here, we would be subtracting that from the target and seeing if we could get a pair of numbers that sum up to this. So this is like this. We would be using 2-sum on each of this to see if we would be getting a value such that this and those two is equals to 0. Okay. For this, what we would be doing is first sorting this array and then have a for loop that runs from I equals 0 to I equals to n minus 1. And each position we run 2-sum in the array and what array of I minus of array of I, because we want to sum this to 0, right? So we will be having this and we will be getting this value such that this is going to equals to 0. And if you remember in the 2-sum 2 problem where we had a what we had a sorted array, so we are also sorting here. When we have a sorted array, we could just have two pointers, one at the front and one at the rear, such that if okay, while left is less than r and left equals I plus 1 and r equals n minus 1. Okay, so if array of left plus array of right plus array of I is greater than 0. So if this value is greater than 0, what we will be doing? We will be decrementing the right pointer. Now, if you want to know why we are doing like this, check the other video of the 2 sum 2 problem and you will be having more clarity. So the other condition would be if this is less than 0. If this is less than 0, we will be incrementing our left pointer. Okay. Else in the sense, if this thing is equals to 0, what we will be doing? Appending our answer, pushing these three, left array of left, array of right, and array of I, and then we will be incrementing our left pointer. Here we would be also checking the condition of duplicates. Because they said the answer solution must not contain duplicates. So we would also be looking out for that, and I would be showing you how we would be doing that in the code itself. So as you can see, this is the optimal solution that we could have. Now, because we are having a for loop, this is O of n, and this could also run till n in the worst case. So O of n into n, which equals O of n squared. This is the time complexity. Now, for the space, as I already said, if we don't consider the answer array as taking up memory, then our space is O of n. And in some cases also, sorting takes O of n space. But we would also be considering, in this case, sorting to be taking no memory, so our space would be O of 1. Now let's get into the code and see how we would be doing this. Now I just wrote what all I said in here. Okay, so let's just quickly get into the code now. Okay, first what we will be doing is having a vector of vectors to store our answer basically. Okay, now as I said, we will be having a for loop that runs from 9 equals 0 to I less than dot size minus 1 dot size 9 plus plus. And each case what we will be having is left pointer, which is I plus 1, and a right pointer, which equals dot size minus 1, and right left is less than right. We will be having our condition. And as I already said, we would be having duplicates in this way. So what we need to do is have a condition for that. If ounce of I equals ounce of I plus minus 1. So, and what I would be greater than 0. We will be continuing. Okay, and we have to also sort the array, right, in this case. So I forgot to write that. So begin. Okay, so this is for sorting, this is for initializing the array, this is for duplicates, and this is the main logic that we have. So as I said, we would be having three conditions. If nums of left plus nums of right plus nums of I equals 0, right, is greater than 0, then we will be decrementing our right pointer. Else, if this is less than 0, we will be incrementing our left pointer. Else, what we will be doing is, else in the case it is equal to that, so we would be pushing the answer to our array. Now this has to be a vector, so this is how we will be doing. Nums of I, nums of left, nums of right. Okay, so there is also one more condition that we have to check for. So the other condition that we have to check is, because we could have duplicates in this, we have to move our left pointer until we don't have the duplicates. So this is how we could do that. Right. If we increment only one pointer, that would be enough. The code would be taking care of the rest. Okay, and here we return the answer. Let's submit this and see. I seem to I didn't put into here. Let's run this again. Okay, I also did not declare this. Okay, and this has to be this. Here it should also be an else if condition, so sorry for that. If we submit now, we got that. Let's just submit this. So as you can see, this is the most space and time optimized solution for this. So thank you for watching.